We're doing all of 1-5 today. Here we go, 1-5. 1-5 has really two concepts that really go well when you split them up, but we're going to push it all together today. So we're going to do two things. We're going to do parametrics, which is new to you. We're going to do them by hand and on our graphing calculator. And then we're also going to do inverses, which you did a little bit last year in Algebra 2. Parametrics and inverses. I'm not writing very well today on this iPad. Okay, so here we go. Letter A. Okay. We're going to talk about parametric curves. And it's just a different way to graph relations. Sometimes our parametrics that we graph are going to be functions, and sometimes they're not. So here's what a parametric curve looks like. You have x and you have y, okay? And they're all going to be x, y points. But x is a function of t. We call it f of t. And y is a different function of t. We'll call it g of t. And t is not a third variable in a way that... Are you, though? Are you?
No.
I didn't think so, yeah. But thank you for saying. That was really nice. T is not a third variable in that sense of a three-dimensional graph. T is called the parameter. Okay? And all of these things, what we're going to do is we're going to take t, we're going to plug it in, and the points that are going to be on our graph are still on an xy plane, and all the points that are made up of xy. And now that I've confused you enough, let's do one. Here we go. Yes. All right. Number one. We're going to do two of these. And one we're going to do by hand. And then the other one we will do on our calculator. Because your calculator can do these too. And you'll be required to do both. Because the next test, which is next Friday, is going to have both. Okay. So here we go. X is equal to the square root of t. And y is equal to t plus 2. And they're going to restrict t this time. Sometimes they don't restrict t, but they're going to say t has to be greater than or equal to 0. And that should make sense if you look at the x value. It has to be greater than or equal to 0. Okay, so what we're going to do is a couple of things. First thing we're going to do is we're going to make a table of values, and then we're going to plot the points from our table. So here's what your table looks like. You're going to have two lines going down and one across. So instead of a t-chart, which has just simply x and y, we are now going to have t, x, and y. Okay? And so what we're going to do is we're going to pick values of t. And they tell us t has to be greater than or equal to 0. So why don't we just do 0, 1, 2, 3, 4. And I think the book tells you to do, they'll tell you what t's to use sometimes, which is nice of them. So here we go. Let's find out our first point. Our first point is to take t equals 0 and plug it into these functions up here and find out what x is. So x would be 0. And then plug in t equals 0 into this one to find out what y is. Y equals 0 plus 2. So y is 2. So what that means is I have my first point on my graph is going to be 0, 2. Okay, let's find another one. Now plug in 1. 1 goes into t. The square root of 1 is 1. 1 goes into t here. 1 plus 2 is 3. So that would be the point 1, 3. You don't have to write that every time. You can see it in your chart. Now plug in 2, and you get the square root of 2, which is an irrational number, kind of gross, 1.14 or something. And then plug in 2, and you get 4. Do it again with 3, and you get rad 3, 5. And then finally do it one last time with 4. Square root of 4 is 2. 4 plus 2 is 6. Okay, so what I'm going to do is I'm going to graph the 3 nice points and see what it looks like. Okay, so you go to a basic, part B is to graph. You go to a basic XY plane, and you're going to plot these points. So I have the point 0, 2. And then I have 1, 3. And then at this point, it looks kind of linear. But then I have 2, 6. 2, 1, 2, 3, 4, 5, 6. And it curves out. And so it starts at t equals 0, and it goes up like that. Pretty cool. So it's half of a parabola. Half of a parabola that's shifted up 2. All right. Now the third thing that we're going to do is we are going to, and this is what the book calls it. It says determine a direct, I'll write this down, direct algebraic relationship. It's very fancy the way they word it, so I want to write it down so that you see it. Algebraic relationship between x and y. Okay. Between x and y. What that means is it's a fancy way to say eliminate t. Get rid of that parameter. Write it the way I normally write graphs. Okay, don't have t in there. I want it just x and y like I'm used to. That's what it's saying. So here's what you want to do. You can do this a couple of ways. One is you can, so we have x is the square root of t, and then we have y equals t plus 2. Now if you look at the graph and you can tell what that is, it's just a parabola shifted up 2 and it's just the right side of it. You can write an equation from there, or you can do some substitution down here. Okay? So here, let's go ahead and let's solve for t. So I get x squared equals t. So I squared both sides. And then I'm going to take t equals x squared, and I'm going to take that x squared, and I'm going to substitute it in to eliminate, to get rid of t. Do you see what I did? So in one of the equations, I solved for t, and then I took it and I plug it in, and so what I get is y equals x squared plus 2. Except I need to add one tiny little thing, because y equals x squared plus 2 is a parabola that's been shifted up 2. But that's not quite this. I need to say that x is greater than or equal to 0. And then that would be the direct relationship between x and y for this graph. Okay? So you gotta tack that little thing on, little part. It's not that big of a deal, but it kind of matters. All right, now, are you ready to see what your calculator can do? Yes?
Is the restriction for t always going to be the part of the answer, or is it just...
No, yeah. In this case, it was, but not always. Yeah. And a lot of times, the ones that we're going to do, there's no restriction on t at all, like this next one. Okay, number 2. So get your calculator out, and let's see how to graph this one. We're going to do x equals t squared plus 2t. Low battery. Andrew. Not you, Andrew. My son, Andrew, yeah. Okay. I got up this morning and I walk out there and all the lights are on. And he's sitting there at the table playing Fortnite at 6 o'clock in the morning. I'm like, are you kidding me? And he's talking to someone. I'm like, who are you talking to? Oh, Nicholas. Nicholas. What are you doing up playing Fortnite at 6 a.m.? It's crazy. Anyways.
There's an awesome coordinator.
Okay. So here we go. Let's do this, and we're going to do it on our calculator. By the way, t is there's no restriction on t. T can be negatives and positives and anything we want. So go to your calculator, and I want you to go to mode. Go to mode. Okay? And I want your calculator to be in radian mode. I know you physics people had to change it to degree. Be in radian mode. Can you not do this every day?
I won't do it every day, don't worry.
Thank you. Okay. And then go to function, and we're going to change from function over to PAR, which stands for parametric. That's what we're doing. It's called parametrics. The one next to it is called polar. Polar graphing is what we're going to do over here next semester. And then, bless you, sequence is like, you know how you did sequences, arithmetic, geometric sequences? You can use the sequence feature of your calculator for that, but we never do, because sequences are functions. So we just stay in function mode. All right, so let's change it to parametric. So your calculator mode should look like this. And then when you go to y equals, things are going to change. Okay? Now, have you ever noticed that this button that you've been pressing for x all along has 4 other things, or 3 other things? X is for function, t goes with parametric, theta goes with polar, and n goes with sequence. They all go with those 4 different modes that your calculator has. So when we write t squared plus 2t, you use that button that you use for x, but now it's t. T squared plus 2t. Interesting, huh? Yeah. And then t plus 1. Okay? All right, so let's see what this looks like. Go ahead and hit zoom 6. And what it does is it only tells half the story. Well, not even half of it. It only graph's part of it. And the reason why is because when you hit zoom 6, parametric is usually used for circles and stuff, and so they usually go from t is 0 to 2 pi, which is a whole circle. Okay, so if you go to window, t is from 0 to 2 pi. That's what 6.28 is, 2 times 3.14. And we don't want 0 to 2 pi. Let's do negative 5 to 5. We want all the t's. Or you could do negative 10 to 10. You could do, negative 100 to 100. Don't do that. It'll take too long. Go negative 5 to 5 and now graph it. Oh, and now it tells the whole story. We were missing part of the graph because our t was starting at 0. Is that a function? No, you just graphed a non-function on your calculator. Your whole life has changed. Okay, so how are we going to, what I want you to do is they might ask you to make a table. Yeah.
Like if we, say for example, if we forget that we put it in parametric one, would that affect other answers like on the test?
Yeah, so that's a really good question. Now that you know parametric mode and you still need function mode, you're going to have to know when to switch back and forth on your calculator. Yeah, and then when you learn polar, you'll have to switch between all three. Ooh, okay. So what I did, hit zoom 6 first, and zoom 6 gives us a basic window, and then go back to window and change your t min to negative 5, and change your t max to positive 5, and then hit graph. Don't hit zoom 6 again. No, hit graph. It's a good range, like negative 5 to 5 of t values. It is random. You could do negative 10 to 10. I've used before. Yeah, no, it doesn't have to be, but it's nice to have it symmetric. Yeah. It'll look like this. X equals something in t and y. Yeah, you can pretty much tell. And then if you want to do a table of values, you can go over to second graph. And that'll give you the table with t, x, and y. Okay? When you go to graph and you can hit trace, it'll have t, x, and y there for you, which is nice. Go to graph and hit trace. And you can go when t equals 0. You can find out that x is 0 and y is 1. Okay? When t equals 1, x is 3 and y is 2. So I like to go over to the table, and then they might ask you for some table of values, but let's just go ahead and graph it. So let's pick some points off of here. Let's pick the point 3, negative 2. 3, negative 2. We'll plot that right there. Let's pick the point 0, negative 1. Okay. Negative 1, 0 is over here. That looks like a pretty good point. And then I have 0, 1. And then I have 3, 2. And so this is just a sideways parabola. Okay. Pretty cool, huh? Not a function, doesn't pass the vertical line test. Sideways parabola. And then if they ask you for a direct relationship between x and y, okay, for this one, since it's not a function anyways, you can go ahead and go to y and solve for t there. You don't want to solve for t up here. That would be horrible. Just solve for t on the x. So solve for t on the y by subtracting 1 over. So t is equal to y minus 1, right? If you solve for t there, t is equal to y minus 1, and then take that y minus 1 and plug it in to the other equation. And you don't have to FOIL, don't worry about any of that, just leave it. It's just y minus 1 squared plus 2 times y minus 1. I know that looks gross, but that is a relationship between x and y. You can tell it's not a function because y is squared. Remember, we talked about that when we were doing functions earlier this week. Okay, so that's parametric graphs. That's, they'll show up again next semester. We'll do them. Once we do trig and all that stuff, then we start doing circles and ellipses in parametric mode. It's very fun. Okay, let's go to part B now. So let's do inverses. We're going to talk about inverse functions. Okay? The inverse of a function, the inverse of f of x is f inverse of x. And that's how we write it. Do you remember that notation from Algebra 2? F to the negative 1 of x. That's called the inverse of x, of f of x. All right, so we have the vertical line test. That tells us if our relation is a function or not. But then we also have the horizontal line test too, okay? So the VLT tells us whether we have a function. Is f a function? Question mark. That's what the vertical line test tests for. Now the horizontal line test, the lesser known of the two, tells us is f inverse a function. Okay? So the VLT for functions, HLT is for inverse. So for example, let's just do a quick little graph here. Let's say I have a parabola. Here's my parabola. Okay? We studied parabolas a lot. Are parabolas functions? Parabolas that open up or down? Yes, they are. You can draw a vertical line. It's only going to hit one time. Now, are parabolas inverses functions? No, they're not. This up here is the inverse of a parabola right here. Okay? It's not a function. You use the horizontal line test on the original, on f of x, to see whether or not its inverse will be a function, and it won't. Because you know what we do? To go from a function to its inverse, we switch all of the points. We switch them. Remember that? A switches with B. So this point that had two y values, or two x values with one y, is now going to be the other way. It's going to be two x's, or one x with two y's, and that's not going to work. Okay? All right. The other thing is, if f passes both tests, okay? It passes both the horizontal and the vertical line test. These are kind of special functions. They are called, do you remember? Or maybe we didn't learn this. They are called one-to-one. One-to-one. It's a fancy kind of way to just say it just passes both. The function is, the original is a function, the inverse is a function. They're called one-to-one. Every x matches with every one y, and the other way. Every one y matches to every one x. One-to-one. Sometimes we write it like this. One-to-one. I know it looks like 1 minus 1. That's 0. But it's not. All right, so what are we going to do with functions? Well, we're going to do a couple of things. First thing we're going to do with functions is we are going to find the inverse. Okay, so we're going to be given a function, and we've got to find the inverse of it. And there are 2 steps to finding the inverse of a function. Here's step number 1. Is you're going to take x and y, and you're going to switch places. You pick them up, and you switch them. Okay? And then the second thing you're going to do, after you switch them, you will then solve for y. Okay. And we're going to do, I have 4 examples of this. We're going to start easy and work our way to hard. Here we go. Number 3. Find f inverse of x. So let's start with a basic line, okay? Someone want to give me a line, f of x equals, give me a slope. Make it easy, 2x plus 1. Perfect. There we go. F of x equals 2x plus 1. So that's a line. A line is 1-to-1. This line is. And what we're going to do is we're going to find the inverse. So take x and y, and you're like, there is no y. F of x is y. We know that. Take x and y and switch them. So x goes over here. Y goes over here. And so we get x equals 2y plus 1. And then we're going to solve for y. So let's get all this stuff over to the other side. We're going to subtract 1 over. So I get x minus 1 equals 2y. And then divide everybody by 2. Now, if you leave it like this, that's okay. But a better way to write that would be y equals 1/2 x minus 1/2. Because does that look like a line to you? Not really. I mean, it is. But isn't that better? Slope, y-intercept. Okay? So that would be the inverse of that function, 2x plus 1. They're inverses. All right. Let's do a harder one. A little bit harder. Let's do f of x equals x cubed plus 5. X cubed plus 5. Okay, this one's not bad, just a cube, it's okay. Let's switch x and y. So x equals y cubed plus 5. And now we've got to solve for y. So we will subtract 5 to the other side. X minus 5 equals y cubed. How do we get rid of that cubed? Cube root, yes. So y equals the cube root of x minus 5. Perfect. See, these aren't too bad. Now, the next one I'm going to give you is going to be a little bit different. So these right here, these were both one-to-one functions. They both passed the vertical line test and the horizontal line test. Their domain and range for both of these were all real numbers for both of them, okay? When you switch x and y to get the inverse, you know what goes along with it? Domain and range switch too, okay? So here's the next one. The next one's a little tricky. Let's say that f of x is equal to the square root of x plus 3. Okay, let's talk about this real quick. We just took that quiz. We had one kind of like this. And if you were to find the domain and range of this function, this is a graph, and it's shifted 3 to the left, and it looks like that. Okay, so let's say you graphed it. You're allowed to graph it. What's the domain of this? X is greater than or equal to -3. And the range is y is greater than or equal to 0. Okay, that we know, hopefully, sure. All right, so here we go. We're going to switch x and y. I'm just going to kind of hang on to that for a minute, that domain and range. Switch x and y. We get x equals the square root of y plus 3. Okay, and what's our next step? Square both sides. X squared equals y plus 3, so that gets rid of the square root, and the square cancel each other out. And then I end up with y equals x squared plus 3. Okay, there's a little bit of an issue here. Oh, okay, there's a little bit of an issue there. -3, thank you. And what happened is I end up getting a parabola that's been shifted down 3. That and that. Okay, that can't be possible. Because remember, I take my x and y's and I switch them all. And that works over here. These x and y's all switch with this, but this is no good. Okay, so I have to go back and kind of fix it. But if I know the domain and range are going to switch, then I know the new domain is going to be, so the range is y is greater than or equal to 0. The domain is going to be x is greater than or equal to 0. X and y switch there too. And what would the range be? Y is greater than or equal to -3. Isn't that cool? Everything switches. X and y both switch. And so if you were going to say this is your answer, the inverse is x squared minus 3, you would need to write as long as x is greater than or equal to 0. Okay? I've had people write only the right side of it, which I know you're right, but that's kind of silly. Okay, last one of these, and we'll get to the last part. For this one, dang it. For this one, it's a little bit hard. So the algebra is tough. So here we go. You ready? F of x equals x over x plus 1. Okay. Here's one of those rational functions, and you know the domains, all real numbers except for -1, all that stuff. But what we're going to do is we're going to just go ahead and switch x and y and then solve for y. Okay? So x is equal to y over y plus 1. Now what makes this problem harder than the rest of them is that you have 2 y's in separate places, but you have to solve for 1 y. Okay? Yeah. So let's go ahead and do it. Here we go. First of all, we're going to cross multiply. Okay? When we cross multiply, we get xy plus x. Don't forget to distribute that x to both of the terms in the denominator over here, equals y. Now, if I asked you, let me just do a little side note here. If I asked you to solve 3x plus 4 equals 2x, right? You would need to get your x's together, right? You're trying to solve for 1x. You're trying to make x equals whatever. That's what I'm going to do here. I need to get my y's together, okay? So what I'm going to do is I'm going to subtract this y over to this side, and I'm going to bring that x over to the other side. I know, I just did 2 steps in one. We bring minus y over here, minus x over there, okay? And here's the trick to solving these rational function ones. You're going to then take this y, and you're going to factor it to the front, okay? And what we do is we will end up with y times x minus 1. And do you see what I just did? I got 1y now. Good, huh? And then finally, divide to solve. So y is equal to negative x over x minus 1. And that would be the inverse. All right, that's way more than you did last year. That's the honors, advanced math part of this. That's the hard part. We'll do one more of those. I did one in 2 in my other class, and it worked out better. The second one did. Okay, so let's do this one. Let's do f of x is equal to x plus 3 over x minus 2. Okay. I'm going to write down the domain and range for you real quick. You can figure out the domain of this. It's all reals except for 2. Good. X is not 2. And then the range would be a little tougher to see, but you could graph it. There's a horizontal asymptote at 1. So y is not 1. Okay? Yeah, just believe me. It is. I figured it out. Okay. I believe you. All right, so let's do it. We're going to find the inverse. We're going to switch x and y. So here we go. X equals y plus 3 over y minus 2. Okay, same problem as last one. Same exact steps and everything. So we're going to start by cross multiplying to solve for y. So you get xy minus 2x equals y plus 3. Now in this step right here, you want to get all your y's to one side, everybody else to the other side. So let's subtract y, so xy minus y, and let's bring that 2x to the other side. Add 2x over and you get 2x plus 3. Okay. It's kind of nicer the second one, huh? You kind of know what you're doing a little bit now. So what's the next step that you're going to do? You're going to factor that y to the front, and then you'll get x minus 1. Okay? And then finally, last step, divide. And so the inverse is 2x plus 3 over x minus 1. And that's the inverse. And guess what? If I ask you for the domain and range, you don't have to really work for it at all, because you already found the domain and range of the function, of the original. The inverse is just going to switch x and y. So instead of x can't be 2, it's y can't be 2. And instead of y can't be 1, it's x can't be 1. And they go along with it, and they switch. And isn't that true? X can't be 1. I know. Isn't that so good? You love it. Okay, I got one more part of inverses, and that is to verify. All right, we're going to verify 2 ways. One way we're going to verify is graphically. If you're going to graphically verify that a function and something else are inverses, then they are going to be symmetric over the diagonal. Symmetric over y equals x. Okay? Like, for example, we did one earlier. I'll just draw it for you since we're kind of running out of time. My iPad's dying. It was a cubic function, and it was shifted up 5. And it looked like this if you graph it. Okay? And then we ended up doing the cube root, right? And what that one looks like, if you were to graph it, because we don't really graph cube roots a lot, but it would look like this if you graph it on your calculator. And what happens here is you can kind of tell it's symmetric over the diagonal. Okay? So like, for example, this point relates to that one. It's just all the x's and y's have switched. This point relates this one and this one. See, this is the point 5, 0, and this is the point 0, 5 up here. Everything's been switched. Okay? So So that's graphically. That's all well and good. It's a nice, cute picture. We're going to really spend the time doing this is algebraically. Now, to determine or verify if two things are inverses algebraically, what happens is this. Take the number 9, for example, okay? Take the square root of 9. What do you get? 3. Now take that number and square it. What do you get? You're back to 9, okay? So inverses, they kind of undo each other. So if I'm going to take f of g of x, it's just going to equal x. I get the same number right back, okay? So to verify algebraically, you really are supposed to show both ways, but I'm just going to let you do one, okay? The book might say verify by showing this and this. Just do the one way. We don't need to do both. Okay? It just takes too long. All right, so here we go. What number am I on? 4? 5? 4? So let's say that, let's do this one. F of x equals x cubed plus 5. And g of x is equal to the cube root of x minus 5. And we showed graphically what it looked like, but now we're going to verify it algebraically. Okay? So let's just pick one way. It doesn't matter. Bless you. It doesn't matter which way you pick. Okay? You should get x. You're going to get x. You'll know that you got it right if you get x at the end. So let's go ahead and just do f of g of x. We could have also done g of f of x. So we're going to take g of x, which is this entire thing. We're going to pick it up and place it into the other function. You should be pretty good at this. We did this on the quiz. Most of you guys got this part right. So we'll go the cube root of x minus 5 cubed plus 5. And you can kind of look at that now that you're an honors student. You'd be like, oh, you got some algebra foreshadowing. Do you see what's going to happen? Yes. Or it is. It's a thing. Algebra foreshadowing? Yeah. And you're like, okay, that's going to go away. No, it's not a joke. It's true. And then you get x. Yay, and you verified, okay? It kind of undid each other, and then you get your same number back. All right, we're going to verify one more. You're going to love this one. We're going to verify that last inverse that we found. That big fraction one. So let's say that f of x is x plus 3 over x minus 2. And then we found its inverse to be 2x plus 3 over x minus 1. Okay? What we're going to do now is we're going to verify. We're going to it's like a proof almost. We're going to verify. Yes, you have some algebra foreshadowing. You're all groaning. Yes. Yes. It's really good. All right, so here we go. We're just going to do one way, just one way, and then I have a trick for this that you're going to like, okay? I do, to make it so much easier, because you're seeing this, and you're looking at this like there's going to be fractions inside of fractions, and it's going to be awful. But there's a good way to do this, okay? So here we go. We're going to take g of x, our inner function, which is this right here, and we got to plug it into f in 2 different places, and for both of those x's, okay? Yes. You can groan all you want, but this is going to be awesome. So up top, it's x plus 3. So instead of x, it's 2x plus 3 over x minus 1 plus 3.
Isn't there another plus 3? Yeah.
I did. It's right there.
Oh, okay.
Yeah. And then over, on the bottom is x minus 2. So now it's 2x plus 3 over x minus 1, and then minus 2. Yep, you were right. There was another plus 3. What was that? Oh, okay. All right, so here it is. And that looks terrible, right? It's a terrible algebraic expression that you have to simplify. You know what this is going to equal? X. It's going to equal x. How? Okay, this is what I want you to do. Here's the trick. You're going to take and you're going to multiply x minus 1 over x minus 1. Okay? And you're going to love this. This works every time. No matter what, these denominators will be the same because you're plugging in the same thing for that x. So multiply by that denominator. So we're going to take x minus 1 and we're going to distribute it. And when you do that, the x minus 1's reduce, leaving you with 2x plus 3. I didn't need to write that in parentheses. And then here you get 3x minus 3. Yes, do you see that? Yeah, it cancels out, as you guys like to say. X minus 1 and x minus 1 reduce, and then you multiply here. Same thing on the bottom. Multiply through by x minus 1. I don't need the parentheses here. So I get 2x plus 3, and then multiply it to this one also, and you get negative 2x plus 2. Okay, now our fractions are gone, and then we get a 2x plus a 3x is a 5x, because the 3's cancel out. And then in the denominator, the 2x and the negative 2x cancel out, and 5x over 5 is x. Yay!